Hello, and welcome to Green Building Research Institute's second course on Indoor Air Quality Post-Occupancy. This is the third course in our Spotlight series, where we are looking at specific green building issues and discussing the strategies that can be applied in a more in-depth way. I am Rebecca Joan Brown, and I will be leading the course today. This is a 200-level course that is lead-specific for BD+C, ID+C, and O&M specialties, and will qualify for 2 lead-specific CE hours. This course is also worth 2 AIA Sustainable Design hours. We will be discussing different definitions for indoor air quality and looking at how air quality affects the health, productivity, and outlook of building occupants. We will discuss specific strategies for improving and maintaining good air quality for new and existing projects after they are occupied. We will also discuss the credits in the 3 biggest LEED rating systems that relate to indoor air quality post-occupancy. The most prominent effects of indoor air pollutants are those that relate to occupant health. There are 2 classifications for the health effects of indoor air pollutants. Those that are acute, meaning that symptoms occur immediately and subside when the irritant is removed, and those that are chronic, meaning that the effects of exposure build up over time and symptoms may not show up until many years after exposure. Acute symptoms of poor indoor air quality include nausea, dizziness, asthmatic symptoms, fever, headaches, allergic reactions such as rashes, and irritability. These symptoms are also typical of sick building syndrome, which is closely associated with poor air quality. Chronic symptoms develop from repeated exposure over time and are often more severe. These types of symptoms are often more extreme in people whose occupation requires them to come in direct contact with sources of indoor air pollutants regularly, such as painters, custodians, carpenters, carpet layers, and other members of the construction trade. Over time, exposure to harmful chemicals and components leads to permanent damage, especially to the respiratory system. VOCs, or volatile organic compounds, are naturally present to some degree and are released from combustion reactions. These compounds are also found in thousands of building products, including paints, sealants, insulation, adhesives, and furniture finishes. VOCs are gaseous at room temperature, meaning that they off-gas from building products and are easily inhaled by building occupants. The levels of VOCs recorded in one EPA study were consistently 2 to 5 times higher indoors than outdoors. Interestingly, this was equally true for urban and rural environments. Because there are such a broad range of chemicals that fall under the VOC classification, there are also a broad variety of health effects caused by exposure. The most common serious potential health effect from VOCs is cancer. Benzene is a VOC which is a known carcinogen, while formaldehyde, perchloroethylene, and styrene are suspected to be carcinogenic. Other effects of VOCs range from kidney and nervous system damage to eye irritation and headaches. Generally, the more severe effects of exposure to these compounds are reserved for those who work closely with them regularly, those in the construction or manufacturing trades. Building occupants are more likely to experience the more mild symptoms associated with VOCs as they off-gas over the life of the building. However, many of these effects are chronic and become more severe with repeated exposure over time. As more research identifies the potential risks associated with these chemicals, alternatives to traditional products are being developed that reduce or eliminate VOC content.